Question number 1. Let's get done with the questions quickly. Water is found in which forms?
All of these.
All of these.
All of these. Water Day is celebrated on
22nd of March.
22nd of March.
our body contains
75% of water.
exactly. Okay, the process of seeping of water into the ground, that is called as
Infiltration.
infiltration or percolation. Aquifers are what?
So
Water
they are the
aquifers.
water that are been stored into like the cracks of the rocks.
Exactly. The water that gets stored into the cracks of the rocks. The water below the ground is known as
Groundwater.
groundwater. Good.
Groundwater.
The large well-like structure which is used in olden
Bowers.
times. Bowers. And this
Bowers,
here
yeah.
you are seeing is Johut. Okay, it is found in India. Okay, so that is actually a kacha well. What that does mean? Basically, the base of this well is not cemented. It's actually, it works like a dam. Okay, so where the rainwater is stored and thereby this is used throughout the year. Okay, so that is Johut. Rainwater harvesting is one of the ways to conserve what type of water?
Rainwater.
Potable water.
Rainwater.
Yeah.
So
Rainwater. This here image which you are seeing here, that is potable water. Okay, I got this this potable water which you are seeing here. What does potable water basically mean? Clean water.
Clean and fresh water, sir. Like the
Clean
water
and-
which we can drink.
Clean and safe water, the fresh water that can be drink. Okay, now let's quickly talk about what are the effects of water scarcity on plants. Like if there's a scarcity of water in human body, then we do suffer from dehydration, right? Thereby the cells are not able to perform their functions properly. Same is the case with the plants as well, because plants also require water to perform a variety of functions. What functions do the plant perform? Like they perform photosynthesis. Right now they also have to do the process of respiration, just like our body does. Because they also require energy now. Yeah, so you see, look at these two plants here. Have a look at the two plants here. Plant number A is getting sufficient amount of water, thereby it is able to perform photosynthesis and do the process of transpiration as well. Clear so far? Now,
Yes.
guys, if you were to look at plant number A here, that looks fresh and good and in good health. And if you were to look at plant number B, whose leaves are basically wilted, looks weak or like about to die. Look at the stomata of the two plants. What difference do we find in the stomata of the two plants?
Sorry, A.
So it's first one is open, second one is closed.
Yes, Chakrika and Vaika?
Sir, in the plant A, the stomata is open, so the carbon dioxide and the oxygen and the oxygen can be like absorbed by the stomata, but then in the B plant, the stomata is closed, so oxygen cannot be entered as there's like no water.
Exactly. But oxygen, you should have better mention about carbon dioxide first. Okay, although oxygen is required for transpiration as well. Good. Yes, Vaiga? That is
So
what
in
you're
A,
observing.
the stomata is closed, and in B, the stomata is, the A, the stomata is open, and in B, stomata is closed.
Okay, that is the thing which is happening here. So we require water for opening of a stomata. In higher classes, you will get to know when water flows into the guard cells of the stomata. These are the guard cells of the stomata that are usually kidney shaped, bean shaped ke hote hain. These are of bean shaped. So when water flows into the guard cells, they basically swell. They start to expand. They start to swell, thereby opening this hole. It opens up, thereby gases exchange can happen there. So plant can do the process of transpiration, that is, it can release the water vapor outside, thereby
Excess
doing the process of
water.
transpiration. Excess water it can remove there, and also during summer season it can cool its body by the process of transpiration. Getting it now? That is the transpiration process. So water that is absorbed by the roots, it goes up the shoot system and it is lost into the environment by the pores present in the leaves. That pore we are calling as stomatal pore.
Tomato.
Stomatal pore. The pores present in the stomata. Okay now. Then we know that in order to perform photosynthesis, plants needs to take carbon dioxide also as the raw material from the atmosphere. Thereby, if the stomata is open, then only the plant will be able to do the process of photosynthesis now. While if there is water shortage, the guard cells does not swell. Thereby, the stomata is closed here. The opening of the stomata is closed. Getting it, guys? So thereby, since it is closed, there is no gaseous exchange taking place here. So thereby, it won't be doing any
Yes, sir.
photosynthesis. So no photosynthesis as well as no
So
respiration.
it will like ultimately it will die, right?
Ultimately, it is going to die. That is what happens basically. So that is the case with the water availability in case of plants, and it will be able to do both photosynthesis and both transpiration. Okay. So this is the common effect of water scarcity on plants. The plants will basically start to lose its leaves slowly. The plant appears to limp and begins to collapse as the plant cells loses the turgor pressure. Now the thing is, what is this turgor pressure now? Huh? Look here. Turgor pressure is basically what? The turgor pressure is, if you were to look at the stems now, look at the stems of the healthy plant, look at the leaves of this healthy plant. Are they fallen like this? If the plant is getting continuous amount of water, are the stems like bent like this? No? You will see a
No, sir.
fresh and healthy plant in a very good condition where the stem is almost upright. Stems are upright. Okay, now whether it's a shrub, herb, or any other plant, you will get to see that the stem is very upright and the leaves are also very healthy. Because in them, there's a continuous flow of water from the roots. Water is continuously flowing upward. So this continuous flow of water in the upward direction generates a pressure in the plant. That pressure has been called as turgor pressure. What did I just say? I said that due to continuous upward.
Sir,
Huh, Chakrika, I'm listening. Chakrika, you
sir, can you explain again? I didn't get it.
Yeah. The thing here is now, look here. If you were to hold a pipe from which water is coming out with a pressure, if you were to hold a pipe from which water is coming out, do we not experience some pressure in that? Like,
We do, sir.
say that a pipe is like this. There's a pipe like this. Okay, now, or say the pipe is in a more bad condition like this. Let's say the pipe is like this, and if I were to turn on the water supply, from the one side, then the pipe becomes somewhat straight like this, somewhat straight like this, because water pressure has developed inside this pipe. Same is the case with the plants as well. Due to continuous upward movement of water in the stems and the leaves, the plant remains upright, okay, and in the healthy condition. And the pressure generated due to the continuous upward movement of water molecules in it, a pressure is generated. It can be understood in the same manner as we understood in the case of water pipe. Santosh Chakrika Vaiga? Getting
Yes,
it
sir.
now? So that
Yes,
pressure
I
has
got
been
it.
called as turgor pressure. So basically, if you stop watering the plants, that turgor pressure is loosed. We lose that turgor pressure,
Yes, sir.
thereby plants basically start to die slowly. So here, this is the condition of the plant, which you can see here. Getting it now? Okay. So that is what happens there. Okay, that is all about the importance of water in the case of plant. Then we have got, like, as we are living in the age of technical advancement, at the expense of what? Like, today we are moving ahead with a very fast pace. We are moving ahead with a very fast pace. Hmm? So there's so many technological outbreaks that we see today. So many innovations are being done, but at the expense of what? At the expense of what? We are basically harming our nature. All the natural resources that we see in the planet Earth, hmm, they are being compromised right now. They are being compromised. So we are building so many buildings. We are doing construction work. We are setting up factories at the expense of spoiling our natural resources. The air is being spoiled. The water is being polluted. The soil is being polluted. So same is the case with the water here, that you get to see the waste that is coming from the cities, okay, from the agriculture, from different industries. All those waste are being dumped into the water bodies. They are being dumped into the water bodies without being treated. So all the different chemicals like pesticides, insecticides, fertilizers, or oils,
Yes.
or battery acids, or the household chemicals or detergents, all of them are being dumped into the water body. Okay, and then pathogens of animal fecal matter, that also eventually reaches the water body. Thereby, water is becoming polluted. So that's why we need to adopt certain measures in order to conserve our water and stop it from being polluted. So thereby, you have got sustainable development goals. There are 17 sustainable development goals. You will get to study about that in later classes. That we have now several sustainable development goals. You must have heard of the term sustainable developments. Yeah, like development is one
Yes,
thing,
sir.
that is okay. Development is one thing. Development basically comprises what? When I say development, okay, for politicians or for the economists or the capitalist people, development basically means growth in economy. Growth in economy. That is what it means now. Growth in economy, um, growth in infrastructure. Are you guys getting it? What I'm trying to say here?
Also, growth in society.
No, they don't count the growth in society usually as development. But if you were to talk about
Also,
human
like as
geography,
in
when you
like
will, हाँ
uh,
Chikrika.
like inventions,
Hmm. I'm saying that.
technology.
Hmm.
Development also means like when you find new things and implement them.
Hmm.
Right. So
Exactly.
basically,
I
inventions also count, right?
exactly. I agree on that point 100%. I am saying that what is the general notion in the society? What is the general notion? What is the general idea about development? That if the economy of a country is increasing, if there are more infrastructure, then it is generally thought that country or that region is a developed one. That is what is thought now. But development in reality are should be counted on basis of social development, as you said, social development. Getting it now? And then it should also be counted on the basis of how good the environment is where the people is living. Okay, if the environment is polluted, if the water is polluted there, so whether the water is drinkable or not, whether the water is drinkable or not. Suppose you have got trillions of economy. Let's say you have got 10 trillion economy. Your economy is of 10 trillion, but then the water there is not drinkable. What the will the people with people do with that much amount of water, that much amount of money? If the water there is not drinkable, if the air there is not breathable, yeah, or if if agriculture cannot be done on that soil, if the soil is polluted. So development should be inclusive in nature. It has to be inclusive in nature, meaning that it should include all aspects of life. It should include all aspects of life. it should be economical, it should be cultural, it should be in natural aspects, it should be cultural it should be in cultural aspects. Getting in what I'm trying to say here? Yes, Sundus, Weiger, and
Yes, sir.
Chitrika, getting it
Yes,
now?
sir, got it.
So it has to be holistic development. It has to be inclusive development where peoples from all sections, from all races, from all caste and religion should be getting the benefit of development. Okay. So now back to our topic. That is, what are some of the tips on water conservation? So these are some of the important tips which we have got, like use a water efficient flush toilet, find and repair leaks, take a quick shower, or use bucket instead of taking showers. Okay. Then convert to water and energy saving faucets, avoid wasting running water as possible. Some of the general things which we all are aware of. Getting it now. Hmm. Now there's a case study I would like to highlight that was given in your NCERT. Bhojpur in the Kutch area of Gujarat has a very erratic rainfall. The only source of fresh water lies underground because rivers in this area do not have water throughout the year. Erratic rainfall means not not
Less
regular,
rainfall.
less
Yes, sir.
rainfall.
Improper rainfall.
Improper rainfall. You can say that because also rivers in this area does not have water throughout the year, and over the years demand from water has grown as the population is growing there. So the withdrawal of groundwater has far exceeded recharge. It means that more amount of water is being taken, is being drawn from the ground than it is being recharged. So the amount of consumption of groundwater is more than the rate of its recharge. So whenever we are consuming more water than it is being recharged, obviously the water table is will be going down or upward.
So it'll be the same basically.
If the rate of consumption of water is more, and here in this case of Bhojpur in Kutch area of Gujarat, there is no
Sir, it'll go
rainfall.
down. It'll go down.
There is no, yeah, there is no rainfall, and the rate of consumption is increasing. Thereby, it will obviously go down, isn't it, Sundar? Getting it now. So in 1989, the villagers, along with a non-governmental organization, that is an NGO, the full form of NGO is non-governmental organization, they decided to harvest rainwater. What they decided to do? To just store the rainwater. So what they did, they built 18 check dams on the Rukmavati River and its many tributaries. So they basically built several small dams on the Rukmavati River that flows in Gujarat. Getting it, guys? Not on the not just on the Rukmavati River, but you see, when a river flows now, rivers have also got branches. Huh? Suppose this red line, it shows the main river. Are you guys there? Huh?
Yes, sir.
Yeah.
So we are there.
So that is the main river here, and it will have many branch rivers flowing out of it. Many branch rivers flowing out of it. So that is called as tributary. What do we call that? It is called as tributary. Getting it now?
Tributaries.
And that is the main river flowing here. Okay. So by the help of check dams, they were able to increase the percolation. Percolation of water was being increased. Why? Because the water that was being collected, it has started to percolate through the soil, and then it was recharging the aquifers or underground water. And according to the farmers, wells have water now, and the water that flowed into the sea and was wasted has become available for irrigation. So earlier, the water in the Rukmati River was flowing where? It was basically flowing into the oceans, thereby getting wasted. In a manner, we can say that it was usually getting wasted. But via the help of check dams, look how the check dams basically work. Suppose this is a tributary. Okay, now this is a tributary, they will make a channel out of that tributary and stop it here. That is a dam here. The small line which you are seeing here, that is a dam. So thereby, this much of area is
Sir,
not storing water. Now water is getting stored here. Yeah.
Thanks, sir. Continue. I was just about to ask that.
Okay. So since water is being stored here, thereby, and you have got no cemented base, rivers don't have cemented base now. Huh? So thereby, it will percolate into the ground, thereby increasing the water tables label there. In fact, several dams were built on the main river as well. Okay. And by the way, dams
Okay,
have got rivers in them all. Sorry, gates in them also. Dams have got
yes,
gates
sir.
in them also. So that in the case, like if the amount of water in the river increases, the dam does not collapses. So if the level of water increases in the dam, then the gates are open. So thereby water can flow through it. Right now.
So, sir, it's not because the shortage of the water in the city. It's because of the increasing amount of the water in the dam that they open the gates for.
Yeah, exactly. That is the thing. Because if they were to not open the gates, then in that case, now the dams will collapse. So thereby, if the dams collapses, imagine lakhs of gallons of water that is stored behind the dam will spread to the nearby towns and villages, thereby flooding so many areas right now. So that is the reason why dams are having gates in them. Okay, so then we get to the question answer part. The question answer part of the chapter is very easy. I believe you guys can solve it yourself. So I will be leaving it up to you guys. Okay, now? Any issue?
No, sir.
I
Sir,
believe
I
you,
don't have the textbook, so
you don't have got the textbook. Why is it so?
like not the NCRT.
Okay, not the NCRT. Okay, other book is being followed in your school.
Yes, sir.
Okay. Anyways, so get done with the NCRT after your exam, Chakrika. Okay. Now let's continue.
Pardon, sir?
Get done with the assignments after your exam is over. Okay, the day after tomorrow, get done with your assignment. The assignments which will be sent to you.
Please, sir, I forgot the class. I mean, the test is on Monday, actually.
Okay, no issue.
It has been
No.
postponed.
Okay. Now, guys, we are starting the new chapter. From the previous chapter, if anyone has any confusion, please do let me know. Sundus, Vaiga, and Chakrika.
Chapter.
No, sir, I don't have any doubts in the previous
Okay.
chapter.
Okay, Sundus, what about you?
No, sir, I don't have.
Good then. Now let's start the chapter light. Okay. So few interesting things which we know about light. What are the things you guys know about light? Do let me know.
So,
So
light
travels
travels
in a
in a straight line. It is said to be in rectilinear propagation of light.
Okay. No.
The laws of reflections of light are incident ray and reflected ray and normal.
Mm-hmm.
And
They are-
the incident ray is equal to the reflected ray.
Good.
So the objects that produce light is called luminous objects, and the objects that does not produce a light is called non-luminous objects.
Very good. Okay. And
So there are terminologies for light, like pole, principal, axis, and there are also different types of mirror, like plane mirror, and in spherical mirrors there are concave and convex mirrors,
good.
and they have different characteristics.
Good. What about you, Sundus?
Sir, I don't have any.
Okay. Okay. I guess Sundus, Chakrika and Vaige have mentioned enough point. Okay. So इनमें से कोई points आपके भी रहे होंगे. Okay. Okay. Let's start the chapter. Now the very basic question is that what is light? So normally we say that light is a form of energy. Light is a form of energy that is coming from where? What is the basic source of light in the whole
Sun.
universe? That is the stars,
Sun.
not just the sun. If you were to specifically talk about the solar system, thereby we see that it's the sun. Getting it now? Now the light that is coming from our sun, okay, or the light that is coming from any luminous body. The bulb here, although we provide power to it,
So
we
the
provide
ultimate
electricity to it.
source of light or the basic source of light?
Ultimate source of light.
So then it is sun, right?
In the solar system, it is sun. When we talk about
So
solar
like,
system, then it is sun. While sun is also a star now.
And you
So
said in the whole universe, right?
in a broader sense, we can say that stars, because sun is also a star. So in a broader sense, we can say that stars are the ultimate source of light in the universe, right? So if you were to move to
yes,
like in, if you were to see in the other galaxies also, there also we have the stars. So that galaxy is also having illumination. So their illumination is also coming from some stars now. The basic idea is that the ultimate source of light is the stars, or in our case, we call it as sun. Okay. So whether we talk about the sun, or whether we talk about a light bulb here, or whether you talk about a glowing candle, all of them are the luminous objects, right? Because they are producing their own light, right? Okay. Now the question is that whenever we study about any form of energy, we try to understand about its pathway, in what manner it is moving, in what manner it is propagating further, right? Now, so if
yes,
you
sir.
were to do an experiment where you take a candle, okay, say this candle here, and if you were to try to uh, align your view of sight to the candle flame, you will be able to see it. Your line of sight is aligned to the flame here. This here is the line of our sight. Okay. Now take a bent pipe then. So here we get to see that we can't see the flame from the other end of the pipe. Why is it so? Because of the
So
Because
property of light.
light travels in a straight line.
straight line, and that is
Exactly.
rectilinear propagation.
Rectilinear propagation of light. Very good.
Yes, sir.
So basic thing is about light is that its propagation is in a straight line. So light travels in a straight line. Okay. Then further, we get to understand that light has got dual nature. It has got dual nature. What dual nature I'm talking about? Like I said,
So, pardon? Can
I'm
you write
saying
the
that.
word down?
Okay, let me write it down. Light has dual nature, two types of nature. What are the two types of nature I'm talking about here? Basically, when we say that light is traveling in a straight line, in what manner it is traveling? It is traveling in this manner, no? Like this.
Yes, sir. The parallel.
Hmm. And this, we say that the lights are traveling in the form of waves. They're traveling in the form of waves. Getting it one, right? What I'm trying to say here. The light is traveling in the form of
Sound
waves.
is the one which travels in waves, right?
Sound is the one that travels in the waves, while light is also the one which travels in the form of waves as well. But how?
Okay, sir.
But how? the thing is that it has got dual nature. Like as I said, it travels in the form of waves. And what about the other nature? The other nature of it says that it travels in particles form also. Light is made up of particles also. Now, can we just digest this fact? Like light consists of particles also. Ever Try to imagine this. Like usually the things which we are able to experience, feel and touch, we say that it consists of some particles, now whether it's a solid, liquid or gaseous state of any matter. Huh, guys? There we see that they are consisting of particles in it. But talking about light, we say that it also consists of particles. And the particles of light are called as photon. These are called as photon. Getting it now? So the scientist Albert Einstein, he suggested that maybe light was not exactly a wave or a particle. Now it's getting confused, huh? The scientist Albert Einstein, what he basically said, he said that light is neither a, like he just said that light is not exactly a wave or neither it is exactly a particle. He said that maybe light is both. So if when you will get to class 11 and 12, you will get to study about the wave particle theory of light. Wave particle theory of light that was put forward by the Albert Einstein, in which he basically said that light is both. It acts as particle also, and it has wave nature also. Just remember these facts. Okay, and the modern scientists have also fully accepted this fact. Okay, now we have different phenomenons, which like phenomenons like reflection. If I were to talk about the phenomena of reflection, light bouncing on from a surface in another, light bouncing off from a surface in the same medium. So thereby we see that light is of wave nature. Getting it what I'm trying to say here? Hmm? Guys, are you there or not? Is it being confusing?
No,
I believe
sir.
somewhat
No,
it is
sir.
confusing. Okay, no, then that is good. So he basically said that light has got both the natures. For to understand some of the phenomena, we considered light to be wave, while to understand some of the phenomena, we consider it to be of particle nature. For example, light bends around an object. If you were to put a piece of rock here, and you were to light a torch from one side. You to light a torch from one side. You will be seeing that some of the light passes. Some of it is obstructed because rock is an opaque object, while some of the light passes from above of the rock. Why is it so? Because light bends around an object.
Sir, can you repeat the point?
I am saying that this is a torch here, and you are lighting a torch on a piece of rock. Okay. So here you get to see that the light rays that are coming, they tend to bend around it like this. See the tilt here? So we say that the light bends or diffracts around an object. So thereby light behaves as what? In this manner. What do you think? Will it be a particle or will it be a wave? Yes.
Sir,
Wave.
can you repeat again?
Yeah, my point here is that I'm saying that this torch is being pointed as this at this rock, and the light tends to diffract from here, diffract or either bend. Light is bending here. Okay, and then there are some phenomena like refraction or like refraction. You guys know what is refraction, no?
Yes, sir. Yes, sir.
Sundus
Yes,
and
sir.
Vaika, what about you guys? Yeah. So
Yes,
when
sir.
light, when light enters from air to a glass prism, okay, or when light enters from air to the water body, if you were to submerge a piece of pencil in water body, thereby you see that its image is slightly distorted. Okay. because their diffraction is basically happening. Okay. Now, now when the light is getting diffracted or bended around an object, we say that in this case, the light has to be understood as particle. In order to better understood the phenomena, we consider it to be of particle nature. Getting it now? Okay,
Got it, sir.
good then. Now, if I were to understand about phenomena, like phenomena like reflection, then in that case, as you know, the light is traveling in the form of straight lines and it travels in a wave, it behaves as wave. Okay, it behaves as wave while it travels in the form of a straight line. What did I just say? I said that it travels in a straight line but behaves as wave. Behaves as wave, just like the sound wave. Okay. So in order to understand such phenomena, light has to be considered as wave. Getting it now? Now, the thing is that what do we call the particle of light, the particle found in light? That has been called as photon. Photon, getting it now? The photon comes, photon
So
in the photon,
proton.
the photon, Photon, photon.
Photon, okay, sir.
So Photon, photon, it basically refers to light. What does it refer to? It refers to light. Okay. Chakrika, is the whole point clear or not?
It's clear, sir.
It's clear? Okay.
Yes,
So
sir.
the nature of light is twofold. It is of two types. So it can act as a particle and it can act as a wave, depending
Wave.
upon different situations. Okay.
Okay, sir.
All right then. Now moving on, let's understand the phenomena of light, like the reflection of light. What is basically reflection of light? Like whenever an object hits, whenever light hits an object, out of these three, either one thing will be happening. For example, if you have got a surface like this, okay, or a sponge surface like this, or let's say this is water body, or you have got a piece of glass here, and this is soil particle here. So the light rays that will be falling on all these objects will go through different phenomena. Look at how all of the light rays are falling parallel to each other. They are parallel to each other while they are falling on the surface. Getting it?
Yes, sir.
Okay.
Sir.
So if you were to look at surfaces like soil, in soil, what will happen? Most of the light rays are absorbed.
Sir, it's basically irregular reflection, right?
Irregular deflection, get exactly. The light rays you will get to see, they will bounce back in different directions like this in a zigzag manner. While in the case of water, it will start to bend like this. It will start to bend like this. So in the case of water also, some of it will be absorbed while some of it will be reflected as well. Because calm water also sometimes acts like a very smooth surface. A calm surface, a calm water also sometimes acts as a smooth surface. Okay, now thereby it also acts as smooth surface, and thereby light can get reflected from it as well. Talking about the glass, pure reflection will occur here. So based on different types of substances, different things can happen. Either it can be absorbed, either it can be reflected back. Getting it now? So let's understand about the phenomena of reflection in detail here. So reflection of light can be defined as the phenomena of an object which throws back the light that falls on it. So hence the reflection of light changes its path. See, you have placed a mirror here. Usually a plain glass mirror has got a silver coating on its back. Yeah, there's a silver coating on its back. And the light ray that is falling over it, Suppose it is coming from this side. Okay, getting it now. So if it's coming at an angle of 90 degree to it, or if it is coming to it at an angle like this. So in the both cases, what will happen if it falls on it at an angle of 90 degree, the direction in which it was coming in this direction. Now it will return back in the same direction. Getting it, guys? Sundus, Vaiga and Chakrika, is it
Yes, so
being
it will
clear?
bounce back, right?
That is, yeah, Vaiga, that is what?
So I told like it will bounce back.
It will bounce back exactly in the same direction in which it came. Okay now.
Okay, sir.
And then talking about if it were to fall at it at an angle, if it were to fall at it at an angle, suppose you draw a normal here, you have drawn a normal here. If it were to fall at an angle, let's say x degree here, this is an incident ray. The ray that is falling on the mirror, we call it as incident ray that is falling over it. So it will bounce back at the same angle of x degree. Now someone will say that, so what is this straight line between the two rays? We call it as normal. Yes, Chakrika? Why can on this? We call it as normal here.
Okay, sir.
Getting it? So that is the incident ray, and then that is the reflected ray. Now suppose here I have taken variables. Suppose if I were to say the incident angle, this incident angle, that is the angle here which you are seeing here. Now this x degree is its angle. If I were to say it's 30 degree, the incident ray that is falling on this mirror, it's forming an angle of 30 degree with the normal. What will be the reflected angle?
So it'll also be 30 degree because incident ray is equals to the reflected ray.
Exactly. That is the thing. Okay. So it will also be getting reflected at an angle of 30 degree. So that is a property of the normal mirror, or basically a surface that reflects the light. Few things we get to know about it is that one thing is common, that light rays are getting reflected into the same medium. The medium here is what? Air. The medium here is glass. Is the light percolating the glass? Is it infiltrating it? No, it's
No,
not
sir.
passing through it. Okay, now. So it basically reflects back into the same medium. And at what angle it will be getting reflected? It depends on the angle at which it is falling over the plane surface, over the plane mirror. If it falls at an angle of 90 degree, it will return back at the same angle. So guys, Sundus, Vaiga and Chakrika, do tell me, like if the angle of incidence for this ray was 90, what would be the angle of reflection? I is for
90.
that will also be 90 degree.
90 degrees, sir.
Getting it now? So Sundus, is it clear? Chakrika and Vaiga?
Yes, sir.
Yes.
Okay. So we saw that there are certain situations in which a mirror like this, or a shiny surface, like if you were to purchase a new spoon from the market, from a steel spoon, in that also you can see the light rays are getting reflected. So shiny surfaces or a piece of mirror, they are known to reflect the light. Okay now. So a shiny metal can also act as a mirror. In fact, in the ancient times, the mirrors were not made of glass, but they were made by polishing a metal. The metals were highly polished, thereby it acted as a mirror in those days. Getting it now? Okay. So polished surface has got what capabilities? What can a polished surface do to the light rays? You guys do tell me. What change can a polished surface bring in light? It's simple. We have been talking about it. It changes the direction of light now. Guys,
Yes.
it changes the direction of light. That is what I'm basically saying. Okay. So a mirror is generally any shiny surface that can reflect backlight. A mirror that has a plane surface will be called as a plane mirror, but then we have got curved mirror as well. Okay, so curved mirrors are also of two nature. If the reflecting surface, the surface from which the light is getting reflected, if it is like this, we call that as what? If it is like this, and the behind surface of it is actually the silver coating over it, and this front surface of the mirror which you are seeing, that is the reflecting surface. Okay, so that type of mirror, what do we call that? Where
Curved
where
mirror.
it is bulging out. Obviously, we call it as curved mirror. But then curved mirrors are also of two types. One of the type is concave, and the another one is Chakrika, that is convex mirror, right? Yes. Are you guys getting bored? Yeah.
So can you just explain it one more time?
Yeah, sure. Look here. The mirrors that have got a curved reflecting surface. This reflecting surface here is curved like this. Okay. So here we see that the reflecting surface is bulging outward now. It's bulging outward. Thereby, we say it to be curved mirror. And the curved mirrors are also of two types. One of them is called as concave mirror. The another one is called as convex mirror. So here in this case, that's a convex mirror. So if the reflecting surface of the mirror is bulging outward like this, then it is called as convex mirror. Sandus, is it clear? Vaiga and Chakrika.
So this mirror is called convex mirror.
This
Yes, sir.
this
It's
this one is a convex mirror, Sandus.
Okay.
And then if the bulging surface is bent inward like this, look. If you were to have a mirror like this, now you see the surface, the reflecting surface of the mirror is bent inward. It is bulging inward, not outward. Thereby, we say it to be concave mirror. We call it as concave mirror. Now look here. You guys must have used magnifying glass or played with the magnifying glass, right now? Magnifying glass. So what type of lenses do you find in that? What type of mirrors do you find in that? Actually, that is
sir,
a lens.
concave, sir.
No, that is convex now. It bulges outward now.
Sir, but then the convex mirror shows the like the virtual images, right? But then
Yeah.
the thing we see on oh yeah. Yes, sir, yes, sir, sure, sorry.
No issue. So the magnifying lenses which we get to see, okay, the magnifying lens that if you were to direct the sunlight over it and place a piece of paper or some dry leaves beneath the magnifying glass, it can burn it after a few minutes. Okay. So that you must have used. So in that, basically, convex lens are used, but with the example of that, you can have an idea how convex mirror looks. So convex mirror also has got the same reflecting surface as a convex lens has. And then you have the concave mirror. Getting it? Okay. Now, before we move on to the laws of reflection, there are a few important things we need to know. Like, if you were to look at the image formation, like generally when we look into the image, generally when we look into the mirror, we see our face, but actually what we see in that mirror is actually a reflection of our image. Obviously, this is not a real image that is
Yes, sir.
forming behind the mirror. So hence it is known as an image of our face, right? Okay. So thereby what is basically happening? Hmm? How the images are formed there. Look here. How an image is basically formed there. Hmm? Are the rays are actually, look here. Let me just come back to the example of magnifying glass which we're talking about. If you were to see, this is a piece of magnifying glass like this. And if you were to project the sun's rays over it, you will get to see that the sun rays converges. They converges at a point now.
Yes, sir.
Okay, and this point, let's say in the behind of this lens, you have placed a piece of paper. You have placed a piece of paper. After some time, it starts to burn. That is a common thing which we observe in it. But the thing here is now that if you were to look here, this spot that is formed here, this spot that is formed here, that is actually the image of sun form on the piece of paper. That is image of sun that is formed there. Getting it what I'm trying to say here? Yeah, guys, I'm saying that when we project sun rays on a magnifying glass and you place a piece of paper beneath the magnifying
So
glass,
what were you saying?
I was saying that
For
when you project the, no, sure. I was saying that when we project the sun's rays on a piece of magnifying glass and then place a piece of paper beneath it, or dry paper, what do we observe? That a bright and very small spot is formed on the piece of paper. That spot will be round in shape, and that is actually image of the sun formed on the piece of paper right now. And now if you were to look at this phenomena, while let's say Sundus is doing this, Sundus is projecting the sun rays. If you were to look at it sideways, will you
I
be
couldn't
able
hear
to?
anything.
Am I not audible, guys? Am I audible to all of you?
Before you were breaking, so I
Yes.
couldn't hear anything.
Is the same issue happening with all of you? Chakrika,
No,
Sundus,
Yes,
Vaika?
before your voice
it
was
is.
but now
Your
it's
voice
okay.
is clear for me, sir.
Okay. Okay, look, I will be resharing my screen if that is the problem. Or is the same problem happening again? Am I audible
No,
now?
sir, it's fine now.
Fine now,
Sir,
no?
you're audible for me.
Okay. So I was basically saying that when the sun's rays are falling on a piece of magnifying glass, then on the piece of paper, its image is being formed. So, like if you were to look at this phenomena, anyone who is doing this phenomena, from sideways, if you were to look at it, or from bottom, if you were to look at it, do you see the rays actually converging to the point? You see the rays are like coming. Can you see the
No,
rays
sir.
coming
They'll be
and meeting
diverging.
that point? So that's a different thing. That's a different thing. We are not going there. I am saying that it appears as if the rays are coming to converge at that point. It appears that they are passing through this magnifying glass and then converging at that point. Getting it? So the rays here appears. Rays appears to converge. Converge basically means come to a point, meet at a point. Okay now. So rays appear to converge, but there's not
Yes, sir.
actual convergence of the rays of light. The converge basically means to meet at a point. Getting it now? That is what converge means. Okay. Okay then. Now coming back to this plane mirror here. Somewhat same phenomena happens in the case of plane mirror as well. You have suppose a plane mirror here. Suppose someone is here. Okay. Now let's take this plane mirror in another form. In this manner, it won't be you won't be able to understand. Suppose there's a person here. Suppose there's a person here who has raised in his which hand? right hand. Okay. So on the mirror, he will get to see his image. Okay. And where he will be raising his, it appears as if he is raising his left hand now. Okay. Left hand. Now, again, in the case of this mirror as well, are the rays that are coming from this person and falling on the plane mirror? You know how image is formed? When do we get to see an image? What are the criteria required for formation of image? There has to be some source of light. If you are in a
Yes, sir.
dark room, if you are in a dark room and there I have placed mirrors on all the four walls, will you be able to see your image um, in the plane mirror? Obviously no, because
No,
for
sir.
formation of image there has to be a source of light, right? And how the
Yes, sir.
image
We need
forms?
object and light.
Exactly. And how the image was formed in this case? Because light rays were coming from the object, because that was a luminous object, so it was coming from it. But in our
Yes.
cases, does light emit from our body? Obviously no. That's a
No.
stupid question. Light does not emit from our body unless we are born. Okay. Anyways, so light rays basically reflect from our body. Our body might be getting light from a bulb. See, the light rays are falling from the bulb on our body, and then it is reflecting and then falling on this piece of plane mirror. So here also, if you were to go behind the mirror, does the rays actually appear to be
So, your
converging?
voice is breaking.
Okay, again, is it breaking?
Sir?
Yeah, am I audible now? Guys, am I
Yeah,
audible?
no, sir. Now you're audible.
Okay, so I was saying that reflected rays, in our cases, we are since a non-luminous body. In our case, the light rays that falls on our body from from a source of light, it gets reflected from our body, then again falls back on a plane